I hope you all are having a good day. So I'm just quickly going to share my screen before I do some introduction. I'll quickly share my screen. Just give me a minute. Okay. I believe you all can see my screen currently.
Yes, I can see it.
All right. Okay. So welcome to this class. So before I start, I'll just briefly introduce myself. My name is Rising Odegwa, and I'm a data scientist, machine learning engineer, also a software engineer, and you can call me like a jack of all trades, kind of like that. So I use Python a lot. I use Python for web development. I use it for machine learning, very popular in data science and machine learning. And I also use JavaScript. But today I'll be talking about object-oriented programming with Python. So I believe I sent this notebook yesterday. So maybe I believe most of you will have it, and you should be going over it with me during this class. I also believe that most of you have like played with it, and even some of you might even have a good understanding of what we'll be dealing with today. But it's always good to learn again and just to refresh your memory. Okay, so before we start, I would like to just inform you that there are different types of programming paradigm. Okay, there's a functional programming paradigm, and there's also the object-oriented. There are other types. Those are like the most popular type of paradigm in programming. And if you use Jupyter Notebook a lot, if you always work with Jupyter Notebook, which I believe most of you will have worked with, you will have been doing functional programming, whereby you have this top-down approach where you have a particular cell, something like this. You have a cell, you write a simple function, you execute it, it immediately shows you the results. So something like a top-down approach where the first cell has to run before the second cell, before the third cell. So if you try to use, for example, maybe a function in the fifth cell that you've not defined on top, it's going to show an error. Okay, so something like that, kind of like a functional programming. But the object-oriented approach is a little bit different. Okay, so if you look at this definition I have here, it says that object-oriented programming is a programming paradigm that provides a means of structuring programs so that the properties and behaviors are bundled into individual objects. So basically, what people do in using this approach is that they model their problem based on objects. Because if you look at the real world is almost everything is made up of objects, or we can even argue that everything is made up of objects, because each object or each person or each entity belongs to a distinct class. Okay, so for example, if you take let's say humans, for example, the human you can represent the human as an entity. Why? Because it has common characteristics. It has common functions that it can do. As a person, you can walk. Another person can also walk. A person can jump. A person has two eyes, has a nose, has ears, so things like that. So we can say there's a person object, there's a person entity. We can also create maybe say machines can be an object. We can also say maybe animals can be an object. So you can see this idea that every entity can be represented as object is the idea behind object-oriented programming. Okay, so that we can take a person and we can bring out all the characteristics of the person. We can take a person and bring out all the functions of the person and represent them as programs. So that is the idea, the whole idea behind object-oriented programming. And why is this good? Okay, so this approach is good for some particular problem. When you have some kind of large scale problem you are trying to solve, it is good because it helps your codes to be cleaner, because you are going to be representing each entity or each piece of information in your code as an object. It makes your code cleaner and more one. Reusability, people can easily extend your code because, for example, if they want to fix a particular bug, they know the class to go to, they know the objects to go to, so stuff like that. There's also the advantage of modularity. Okay, you can structure your code into modules. So, for example, you all have been working with packages, libraries, where you import pandas, import numpy. For example, if you want to use a particular function in pandas, let's say you want to use let's say you want to create a series. For example, you do pandas.series. That series itself is a class, is an object. If you want to create a data frame, you do series.data frame. That data frame on its own is also another class. So you can see that most packages are bundled as modules, different classes, different objects. If they were not like that, it would be so clustered, and when you are looking for a particular function, you might not know where to go. If you have an error, it will be hard to debug, so things like that. Okay. So I believe we have like a basic understanding of what object-oriented programming is. And also another thing I got here from Python was that an object represents a person, which I've said before, with properties like name, age, address, and also behaviors like walking, talking, breathing, or you could represent an email. So for example, let's leave the person, can be a little bit abstract. Let's talk about maybe an email. Maybe you are trying to create an email program. So you can represent an email as an object in the program. So what are the properties of an email? For you to send an email, you must have the subject, you must have the body, you must have the list, that means the recipient list, who are you sending the email to, so stuff like that. So these are all attributes that an email must have. Then you can have methods or behaviors. What can be behaviors of an email? An email can be sent. So you can send an email. So once you click the send button, it automatically starts this send method. Okay. So an email, you can add attachment. So adding an attachment is a behavior. So you can see we can take this kind of abstract concepts and model them using object-oriented programming. So that's your idea. Okay. So let's talk about what we're going to be learning in this workshop. We'll learn how to define a class, which a class is simply just an object. Okay, so we'll learn to take an abstract concept, maybe like a person, animal, or a student, and define it as a class. Okay, then we'll learn how to instantiate an object from a class. I'm going to explain what instantiate means. And also, we're going to learn how to define methods and behaviors of objects. And fourthly, we're going to learn what is called inheritance, which I'm also going to explain. And then we're also going to learn we're going to talk about extending of classes, extending of parent classes. Okay. So if there are any questions, you can just put them in the chat session. So sometimes I'll just go over it and see if I can quickly answer most of them. Okay, somebody said I like that metaphor of email as an object. Good. Yeah, a cool example, right? Okay, I think brain is handling the questions. So I'll just keep on going. All right, so let's define a class. So we have when we talk about a class is also can also be called a data structure. Because in computer programming, when you say something is a data structure, it's just a structure that can store data in a particular format. Okay, so for example, in Python, you have things like numbers, you have integers, you have floats. An integer can only take a particular type of number. So if the number that you are trying to assign to an integer is not of the type int, it's going to give you an error. So you can see every class or every data structure has their own properties, have their own characteristics. Okay, so you cannot say an animal is a human, and you cannot say a lion, or let me say a cat. A cat cannot reason the way a human reason. A cat cannot get up and say he wants to go to school. So that's not the behavior of the cat. So every data structure is just a way of embodying data so that it can behave in a particular way. So you have things like numbers, strings in Python, you have the list. The behavior of a list is different from the behavior of a number. The behavior of a list is different from behaviors of strings. In list, you can append, you can add new objects at the end, add new values at the end. In integer, you cannot append to the end of an integer. It shows an error. So for example, let's say, let me just add a new code above. I think I should zoom in a bit better. Alright, so for example, if I have say a is equal to, so a is equal to 20. When I run this cell, if I do a dot append, append is a property of the data structure list. So imagine me trying to append to an integer. So it's going to tell you attribute L. So you see when we talk about attribute behavior, attribute simply means behavior. So it's telling that attribute L int object has no attribute append. It does not have this behavior. So that's the whole reason behind data structure. Data structure just represents information in a particular way. Okay? So defining a class is like Python gives you the ability to define your own data structure. So you can like create it the way you want it. For example, if somebody calls print on your class, you can customize a string that will be returned. If somebody calls add, you can customize what add will do, like stuff like that. Okay, so you define a class is like creating your own data structure, but Python comes with primitive data structure. These are like inbuilt data structures, number, string, list, and stuff like that. Okay, so if you need to model more complex data structure, you need a better and efficient way. So the idea behind classes comes from this problem. All right. So let me just delete this, delete this, and this. Okay. So let's just take a typical example. Let's say we are trying to build a program for a school, for example. Let's say we are trying to build a program, a software for a school. So you want to build, let's say, a content management system, or a student management system, or a student management portal. Okay. Hereby we have students, we have teachers, we have let's say admin staff, stuff like that. So you can see that the whole, if you look at this in an object-oriented programming way, if you're trying to build a kind of program like that, if you look at it, most of the times what you first of all do is to try to like picture and draw the diagram of the classes that are going to be in that program. So for instance, if I want to build a portal for a school, what I can do is to first of all identify all the objects that are going to be in my program school. Okay, so I can say students is an entity. Students have a particular behavior, so students will be an object. Lecturers or teachers is another entity. They have a particular behavior, so lecturers is going to be another object. Why the father or the super class is called the school. So under school, you have different objects under it. So school is an object on its own. Under school, you have students, you have teachers, you have admin staff. So these objects have their own behavior. So you can create a particular behavior for students. For example, students can have course taking. Course taking can be an attribute of students, but a lecturer does not take a course. A lecturer teaches a course. So for the lecturer, he or she will not have that particular attribute that the student has. So you can see the whole idea behind object-oriented programming is to make applications simpler. So you already know beforehand what each entity will have. So you cannot try to call course taking on a lecturer class. You of course you already know what each entity or what each object will have. So that's your idea. So just imagine we're trying to build that kind of software. Now we have a student class. Okay, so in Python, to create a student class, you just use this keyword class, small letter, or true. Then you define your class because it always starts with a capital letter for convention. Always starts the name of the class with a capital letter. Okay, so what we've done here is we've created a class. This pass method just simply like tells Python not to do anything. So after clicking this class, don't do anything. So let's run this, and we've just created a simple class called student. But this class currently does not have any properties, does not have any method, it does not have any value. Okay, so you can see say classes are used to create user-defined. Okay, I said this earlier, and they have functions and methods which identify their behaviors, actions, and things like that. Okay, so let's move to this next cell. Now, what we did here is that after creating the class student, there's a special function that Python reserved called the dash dash init dash dash functions. They are called this kind of functions. Any function whereby you start with double underscore, the name of the function, they end with double underscore. It's called a dunder function, something like this. DUNDER. They're called dunder functions. They're kind of a way to represent inbuilt functions. So this init is a Python inbuilt function. So what we are doing here is that we are telling Python that after creating this class of students, if you are going to be creating any object from this student, the object must have these properties. Okay, so what are the properties? The properties are age. I just defined this by myself. Age, a student must have an age. Students should have maybe a class. Then I also added year of admission. So these are like attributes of the student. Student will have age, student class, year of admission. We can also have name. So I should probably just add name. Student should have a name, maybe first name and last name. You can play with that by yourself. But we have name, age, ST class, year of admission. Then somebody might be wondering what is this set function, this set method here. Okay, so in Python, anytime you create a class and you initialize that class, or you are creating a function in that class, the first parameter you pass must be the set. Set means any instance you are going to be creating from this. Okay, so this set is an instance you are going to be creating from it. I'm going to explain what an instance is in the next cell. But just quickly know that any function you are going to be creating inside a class must have this first parameter self before you add any other parameter of your choice. Okay, the next part whereby you see self.age equals to age, self.s equals to this, self.year of admission equals to this. It's called the initialization. This is where we are initializing all the parameters. Okay, so for instance, let me quickly come here. For instance, if you want to create an object from this class, this is a class. The class is like a blueprint, like we said earlier. It carries information, methods, behaviors, and things like that. So for you to use a class, you have to create an instance from it. Okay. So for example, if I want to create a class, which I did here, I call this class Rising, which is my name. Student, you can see this is the name of the class. Student. Then in parentheses, I have name, age, class, and year of admission. So my name, so for example, I'm going to start with, let me call me, this is my name, comma. Then this 20 represents the age. This one represents the class, maybe class 1. Then 2017 represents year of admission. So you can see we have 1, 2, 3, 4, 4 parameters, 1, 2, 3, 4, 4 parameters. The set is by default. It has to be there. So don't bother about it. It has to be there anytime you are creating a function in a class or you are initializing a class. Okay. So I want to explain what is happening here. So for example, we create this student object. If I print it out, takes no, oh sorry, I have to run this. So okay, and I run this. So if you look at the output, you see dot student as this some random numbers here. This is a memory address. So it said it has created this instance of this instance called Rising and stored it at this particular address. So it has created an instance from this definition, from this class definition we gave to it. Okay, so what happens is that these values you pass here, this rising is going to take this rising and is going to assign it to that particular instance age. Okay, so if I do rising dot, you see automatically it gives you all the attributes that are present in the class. So I do dot age and run this, it's going to return this value because I have assigned it to this list. So if, for example, the name now, I've not assigned name during my initialization, I've not assigned name, so I can't have access to name. So if I do name and run this, you can see student object has no attribute name. Why? Because during the initialization, I did not assign it to self. So any parameter you have in your initialization must be assigned to self. So I'm going to just do something like self.name equal to name. So if I run this now and I do it, yes, I'm going to have Ryzen. Okay, so this instance name is called Ryzen. So if I create another student, this other student is going to have its own parameters, but they have the same property, but they are having different instance value. Okay, so for example, this new person, I'll call this person Mike. If I run this as well, you can see, okay, this is the address of this person, Mike. Okay, so if I do dot name as well, it's going to return Mike. It's not going to return Horizon. Why? Because this instance is different from this instance, but they are sharing the same class, the same properties, the same behavior. So the class is like the blueprint of how the person should behave, or how the object should behave, what attributes the object should have. Then once you create an instance, this instance is a thing on its own, is an entity on its own, but it is having the behavior of the class. Okay, so if you've used if you've used, I believe most of you have done some data analytics job or work or project. If you've used maybe class something like a label encoder or a one author encoder, you see that you create an object from the label encoder before you can use it. So for instance, you do something like let's say LB is equal to label encoder, something like this. Then you now do something like LB dot fit. I don't know if you guys have used this, but just an example. So what we did here, this first line, is the same thing we are doing here. Label encoder is a class. So we are creating an instance LB from the class. Then we are using that instance to feed. So this is called instantiation, right? So just take note of that. So I believe we've got this. Let me see any issue. Okay, Ben is taking care of that. All right, so we've created a class. We defined some initialization parameters for this class. We said that any instance we are going to be creating from student must have these parameters. So if, for example, I try to create another student, I'm going to copy this code. If I try to create another student and I omit the name. Let me call this Joe, for example, and I omit a parameter. It's going to quickly show an error that I'm missing one required parameter, year of admission. But is this supposed to be year of admission? Yes, because what we did here is called positional variable. Okay, so you can see what it's going to do is it's going to take this text and assign it to the first variable name. And it's going to take 2 and assign it to age. And it's going to take 2016 and assign it to class, ST class. So year of admission is the one that is missing. That's why you see missing one required positional argument. So we pass the argument by position, not by name. Say for example, we'll do something like let's say age equal to this. Then what's the other one? st class. st class equal to this. Then we say year of admission equal to this. If I run this now it's going to see missing one required positional argument name. So because we specifically passed the name of the variables, it's going to pick each of them and really clear that we are missing this guy. So that's the difference between positional variable and variables that you pass with names. So just take note of that. So you can see that trying to create an object show from students without specifying the right parameter is going to quickly throw an error for you. So these are the things that you can only guess when you're using classes. Okay, so please take note of that. So I'm going to leave that there. Now we've talked about the init function, talked about how to instantiate a new object. Then the next one is called attributes, which I've already been explaining since. So you can liken attributes to characteristics of an object. It describes what an object is made of, e.g. for a student, attributes can be height, age, class, the year of admission, and so on. So this is what something like this, what we have on top. So for you to access the attributes, you just need to create an instance. So if you create an instance from the class, then you can use the dot function. So dot age will return the age. Dot age for Mike as well returns this particular age for that person. Year of admission, same thing. Mike year of admission, same thing, 2015. So this is how you access attributes. So attributes, you don't add the parentheses to it. If I add parentheses and I try to run this, what it's going to say, int object is not callable. Why? Because it's returning an integer 20, so you cannot call it's not a function, it's an attribute. So please take note of that. That's the difference between a function and an attribute. If you are calling an attribute from a class, you don't add your parentheses. Okay? So if you remove that and run this, you can get back the attributes. Alright. So now we've talked about attributes which can be likened to behavior. To characteristics. Okay, that's an object must have. So the next one is called the behavior. What are the things, what are the actions that the object can do? Okay, actions are simply the methods or the functions that are in your class. Okay, so attributes are characteristics. They don't perform any function. They just return a character, just return a description. Okay, but your methods define the behavior. So they do something. They perform actions. Okay, so take note of that. So it said instance methods are functions that are defined inside a class and can only be called from an instance of that class, just like the init. Okay, so just like the init, instance method first parameter is always self, like I said earlier. Okay, so for example, we have this student class again. I have self, age, year of admission. They would define the attributes. Now, inside this class, remember, look at the indentation. Let's take note of the indentation. They are all in the same line inside the student class. If you do something like this, these functions are no longer in this class. Okay, so please take note of your indentation. So you have to indent by one to make sure they are all in the same line. Okay, now what we did here is to define two functions of this our class student. We said the first function is add to year. What add to year will do, add to year does not take any parameter. So you can see just passing stuff, there's no parameter. So what add to year is doing for us is that it's going to take year of admission, which is an attribute. So you can see set dot year of admission, which is this guy. So it's going to take this attribute and it's going to add one to it. So this is just plus equal to 1. This is the same thing as saying, the same thing as this. Okay, so that's just a shorthand of it. So what we are doing is that we are taking what is currently the year of admission for an instance and adding one to it. Then we'll return it into this attribute. Okay, so anytime you call add to year, it will add one to the year. Okay, so this is a behavior, this is a method, this is also called a function. Okay, We then also added another simple function called change class. What change class does is that it takes a new class from you who is calling this function and assign it. So you can see it's going to assign this new class to the attribute st class. So it's changing the attributes to this new class that you specified. Okay, so let's quickly just create an object or an instance. Sorry, let's get an instance from this class. Now this class has attributes. It has two methods or two functions. So let's see how we can access it. So if you do rising students, remember we have age, ST class, year of admission. So we have 21, 2017, which will be mapped to each of them. 20 will go to age, 1 will go to this, 2017 will go to this. So if I call dot year, remember I can still get the year, which is, sorry, I have to run this first. So I still get the year, which is 2017, which is what I used to initialize. Okay, I do the same for Mike as well. I have 2015. Now, if I want to call a method on this object, so let's say we want to call add to year. So if you look at what we did here, we called dot add to year the same way you access an attribute. That's the same way you access a function defined in a class. But this time, you're going to be passing parentheses because this is a function and not an attribute. Okay, so if the function takes a parameter, you have to pass the parameter in this place. So this parameter you pass here will now be passed to the function inside the class. But our add to here does not take any parameter. So remember, this set is by default always there. So please take note. So add to here does not take a parameter. Okay, so it's simply going to take this year, which is, for example, currently it is 2017. So it's going to take this year and add one to it. So if I call this function add to year and I run and I print what is in year of admission, it's going to increase to 2018. Okay, if I call it again, it's going to increase to 2019. Why? Because this 2018 is saved in the instance. So if I call it again, I'm going to add one to it again to increase to 2019. So if I keep calling it like that, it's going to increase until I change it. I will create the instance. So this instance is saved. So it's something called a saved state in programming. Hereby you save variables of that instance until you will create the instance again. So if I keep doing this, it keeps updating, But if I go back and recreate this instance, it's going to reset everything and it's going to initialize it, reinitialize it to this value. Okay? So if I run this now, it's going to be 2018. So please take note of that. So you can see that OOP makes programming easier, make it more easy to fix things, easy to spot bugs, and more cleaner. Your code will be more cleaner. You can easily write clean code. So the same thing with this year of admission from Mike, the same thing, 2016. So let's quickly just use the other function called st class, change class. So I'm going to say rising dot change class. So you can see, because the class is defined in the object, anytime you do a dot, it gives you autocomplete. Okay, so change class. Now it's asking for the parameter new class, which is what we defined here. New class. Okay, because it's that new class that is going to assign back to this class. So I can decide to say give it a class of class 4. Okay, if I run this, it has updated, but nothing happened because we did not return any value. So you can see it just made an update, nothing else. So for us to see that update, you can print st class. So I'm just going to do st class, and you can see it has changed the class to 4. Okay, so great. So you can see that creating, so let me just quickly recap. Attributes are like characteristics of your class. Okay, when you call them, you don't add a parenthesis, and they only return a value. They don't do any computation. They just return a value. But your functions can take parameters like this, or might not take parameters. But remember, you must always add the step Okay, and your functions will do some computation and can maybe return a value or may not return a value. You might update the attribute. So let's just quickly create a simple function to return a value. Okay, so let's just say print. Um, let's call this print name, print age, or let's say print info. Let's call it print info, maybe info about the students. Okay, so what I'm going to do is just let's just construct. Sorry, let's say info is equal to. Now we use a string formatter. Okay, so what we'll do is I want to print the name of the age of the person, the class of the person, and the year of admission. What we'll do, we'll say age. What is the age? Self dot age. Then we'll do let's say class. So we'll call self dot st class. Then we'll do year. Let me just call it year of admission. YOD. So we have self dot year of admission. Okay. So this is the string. So we created a formatted string. So I believe you are all familiar with the F string or formatting string. If you are not familiar with it, what you can simply do with this is that after creating, after adding your code, you paste an F before it. You can access those inside by using this parentheses. Sorry, curly brace. Okay. So we've constructed an info about the student. Then we can simply return. Let's return the info. Oh, so I think I should call this. I should call this get info, not print info, since we are returning the info. Okay. So I'll run this class again. Year of admission, the same thing. This, the same thing. This. Okay. After changing the class in this place, I'm going to do using the get info. Okay. Oh, sorry. Get info is not supposed to take a parameter. So I'm going to remove it. Run this again. Run this. Change class. All right. So in this place now, it's going to return a string. So you can see it returns a particular value after doing the computation for us. So what it returned is age 20 class for YOU 20, so something like that. So you can like try to picture how softwares are built. Okay, so whereby you can say get user. You can, for example, when you log into a platform and you put in your password, put in your username, from your password and your username, they will make a call to the database. If your password matches a particular user in the database, they can do something like dot get user and it returns your info, your information. So it makes it easy to manage
Sorry, Razak.
Yep.
I think there's a question from Boy Pelo in the chat regarding why the curly brackets being used.
Oh, why are the curly brackets being used? Okay, so why you use this is to access functions that are outside the string method. Okay, because this self.age is an attribute here. So if you're using f string, you can say age is age. Normally, let me create this. You can do something like this. Let's say, I'm just call this info to naming. I'm bad at naming things. It's equal to, let's say, boy. So for example, you want to append a new string to this. You can try to do something like boy plus, let's say, that's called girl. And once you try to print this, it gives you a combination of both of them. So, but if you are trying to construct a kind of a long string, it is better to use string formatter. Why? Because you can be able to pass variables to it. So instead of doing, let's say I call this string one, is equal to boy. I have st2 is equal to say girl, and I do something like st1 plus st2, something like this. Combine the two together. I can do the same thing with f string by doing something like this. Now I cannot access the variables, so I can use curly brace to do st1. Then I can write any other text I want. Then if I want to access the second one, I can also do st2. Okay, I can run this. But without the curly brace, if I remove this guy, it's going to just be like a normal string. It's not going to be a variable name. So you can see it's not going to access those values. So that's the reason why we use this to tell Python that this is a variable, fetch that variable and replace it here. This is a variable, fetch that variable, replace it here. This as well. So I believe that's clear. And it's
Thank
okay.
you.
So we are talking about let's get info which we've talked about, we've done that, and I was just recapping saying that attributes, characteristics, they don't return the computation, they only return the value description. Then we have functions which can do some computation. It might return a value, which is like this, but it may not return a value. So it can do some updates in the background. All right, so let's move on to the next section, which is called class inheritance. Now, the idea that we have most entities or most things are made up of objects means that there can be some form of relationship between objects. For example, although we have a student and we have a teacher object, student and teacher belongs to the same class. If we look at it from the top, we can say that both students and teachers are also of a class person because they are both person. Okay, so person is like the parent. Then from the person object you have the student. From that person object you also have a teacher. Why? Because they share common characteristics of the class person. A student will have a name. A teacher will also have a name. Okay, student will have age. A teacher will also have age. So you can see that they are sharing properties. So if you are designing programs or you are designing software, if you have objects that are sharing the same property, it's good to abstract it to create a super class or a parent class. Assign those objects to them. Then once you are creating the smaller objects, you inherit from that bigger class. So we can say that in this analogy, we can say that teachers will inherit the property name and age from person. Students will also inherit property name and age from person. Then they will have their own separate attributes as well. So that's the concept of inheritance in OOP. So inheritance is the process by which one class takes on the attributes and methods of another class. Then the newly formed class are called child classes, and the classes which they derive from are called the parent. So it's just like a parent-child relationship. Okay. So for example, you were born, you have a father, you have a mother. You can take the attributes or the characteristics of your father. You can also inherit the behavior of your mother. Okay. But you yourself can also have your own unique attributes. So it's just like extending what your parents can do. That's your idea behind class inheritance. Okay, so the child classes can override or extend attributes of the method. So, for example, if the parent class has, let's say, a unique name for any child classes, the child itself can override that unique name, can give itself a new name. So you can override an attribute of the parent. You can also extend it. I believe maybe we should see that in practice to be more clear. So remember, student is a class which we created here, and students have all these attributes. Okay, so I think maybe we should create another class called person. I think it is more clear that way. So I'm just going to copy those things. Then on top of this, we're going to create a class, and this class will call it person instead of student. So person we have yes age. There's no need for class because if you have a person, a teacher might not have a class. So let's call this name. No, let's add name. So something that is generic. So let's just say name and age. So I'm going to call this name. So we have age and name as properties. Then let me just say add to age. Okay, let me call this add to age. So to just add maybe the person is celebrating a birthday. So it's going to take the age and it's going to add one to it. Okay. No, I'm not going to use this. So I'm going to remove this. Also, I can look at info. So I'll print the age and I'll paste. I think I should put the name first. So I'll give this name. And I'm going to remove this. So the name should come first. So it's more cleaner that way. Alright, so we have the name and the age. So we have the simple class called person. So the person has two attributes, age and name. Then the person has two methods or two functions, which is add to age, which takes the current age and adds one to it. And we also have the get info, which just prints the name and the age in a formatted string. Okay, so this is our class. So we create that class. Now we want to create a class of students. This is the class we want to create, a class of students. Okay, so we copy this. But I think I should use the other one on top, the one with name, so that you can see that inheriting makes your code smaller. It's not this, not this. Yeah, this guy. No, here was one I defined name. I think I defined name, age, S class. Yeah, this. Where was I? Okay, so I'm going to create a cell above. So assuming, for instance, let's see. Yes, I have all this method as well. No, there's no need for me to use it. I think I should just use it to explain. We're going to create two new classes, one called student and one called teacher. Alright, so we have this. So we have teacher, we have student, we have person. So we are trying to model, let's say, student and teacher class. Now we believe that student and teacher share common properties, common characteristics, and common methods. So, for example, they both have age and they both have a name. Okay, so we can create a super class or the parent class called class person. So, if we are creating a new class called student, there's no need for us to create these attributes again or create these methods again. Since this person class already has it, all we can do is to inherit those properties and those attributes from the person class. And in Python, for you to inherit, you simply copy the name of the class, get the name of the class, and place it inside the parentheses when you are creating your new class. Okay? Also put it here. So what is this line is saying is that student is a new class, but it is inheriting the characteristics, the properties, the attributes, everything that you define in the person class. Student is going to have it. Everything you define in the teacher class, in the person class, teacher is also going to have it. So without even adding new functions here or new functions here, you can create a new instance. For example, let's create a new instance for let's say teacher. If I say let's call this person Vicky, let's say Vicky is equal to teacher and let's say teacher. And you can see we have a name and age. Where is the name and age coming from? we did not initialize any name and age yet. So it is calling, once you do this, it is going to be calling the person class. So it's going to accept the parameters name and age that is defined in this parent class. So it has access to these attributes, it has access to these methods. So for you to create a teacher class, by run this, it will throw an error. You can see missing two required arguments. So it is calling this initialization method first because that is the parent. It's going to call the method of the parent first. So for me to do this, I cannot say teacher, let's say the name of the teacher is Hans, then the age is, let's say, 26. So I can run this now. Now you see, no error. We are able to inherit from the person. So all the methods in the person is available to the teacher Vicky. So teacher.Vicky have a name which you can print out. John. I use John, I use Vicky. Probably maybe I should change this. It's a feminine name. Okay. So I have access to the name. Oh, sorry, I have to learn this again. Okay, so I have John. Now I also have access to the method, so I can call adds to age. So for example, let me first of all print the age. So you can see the age is 26. So I can do John dot. If I do a dot, it's going to return all the methods from the parent class, all the methods and attributes from the parent class. Okay, so you can see get info is a method. Age is an attribute. So let's say get info. Remember function parenthesis. Okay, so if I run this, we will have name John, age 26, and this person is a teacher, but it is inheriting from the class student. So the same thing with students. I can create a student. Let me get a student here. I'll call this student. Okay, I'm going to use Wiki this time. So I'll say Wiki is 16. So I'm creating a teacher object instance. I'm creating a this should be student. I'm creating a student object, but they are both inheriting from class person. Year of admission. Oh, let's see. Oh, this student already created it. Yeah, wow. So I'm going to change the name. So, yeah. What is happening here is that it is calling, here's it, yeah. It is calling the previous class. You can see this class student already created it before. So I'm going to call it, let me just say student new. Let me just call it student new. Student new. Then this student. Okay. Student new is not defined because I've not run this cell. Alright. So we created two instances, teacher and student, but they are going to be having access to, both of them are going to be having access to all these attributes and methods. So if I say, let me copy this, create for me, go here. If I call what's the student Vicky, if I call Vicky dot get info, it's also going to perform the same function. Name Vicky age 16, the same thing. So they can have inherit the classes from the parents, and they can also have their own classes. So for example, I want to add a new class to students. I can say define, let's say, what would I call this now? Get, let's say get class, for example. So you can say return, you're going to output this, let's say return class 2, for example. So this is a method for the student. So I run this again, run this again. create an instance. Now the student Vicky dot now has an extra method called get class. So you can see it has access to the parent method, the parent attribute, and also has access to the new class. So it has like added new function or new abilities. It's like you can take that for example, like like a child that maybe your parents give it to you, you don't know how to dance, but you later on in life you start to learn how to dance. So you now have a new ability that your parents does not have. So something like that. So you can do get info, sorry, get class, yeah, get class. The function is going to, oh, what did I do? Oh, sorry. All your class must have the self. I didn't push that. So if I run, I'm going to just run this again, run this, run this, run this. So you have class 2. But if I try to do that on John, which is a teacher, John does not have this parameter. John does not have this method. So you can see teacher object has no attribute get class, and that's true. So something like this. So this is the whole concept of inheritance. So that's what people building software, they can write a kind of like a generic class to represent low level function, low level attributes that they will use in another module. So they will have to import it in another module and inherit from that first class. So you can see it makes your code cleaner and shorter, easier to use. So you can see just by creating this simple one-line class, you've inherited everything that is there. All right, so let's move on. Is there any question? Okay. So what I'll show you next is just we get to this error is how to extend parent class. Extend simply means oh sorry, we've done extending already. I was way too fast. So I did extending already. Yeah, I explained already. Extending by adding new attributes or adding new functions. So that was what I was supposed to talk about here. So you can see added new functions. So I'm just going to comment this out. I'm just going to comment this out. As well. And yes, all right. So the next one is overriding. So extending is simply just adding new functions after inheriting. So we already get that. So the next one is called overriding parent method. Now somebody might ask, what if you have a function in your parent class that you want to override? Say for example, this get info. I want to add a special string to it to differentiate students from a teacher. So I don't want to use the default get info method that is in the person class. So I want to override it. So what you can do is that you can simply define a new function that is having exactly the same name as the one in the parent class. So what happens is that what Python does is that it simply, I mean, let me just copy this. Let's do it for teacher. What Python does is that it's going to look at the name of the object or name of the function or method and it's going to check if this is the same name with the one in the parent class. And it's going to choose the one in the child class to run. Okay. So for example, in the teacher class, I want to override this method, get info. Okay. So I'll copy this. And add it here. Okay. So I can do let's say name, self.name, age, self.age, and I can add, let me add category. Teacher. Okay, return info. So I'm going to create a new person. Let's say names, Mike here. Mike. create a new object from teacher. Run this. Missing one argument. Oh, sorry. We are inheriting from person, and person always have a name and an age. So let's say I call this Mike, and I say Mike is 90-year-old. So I have this. Alright. So I can do Mike. Sorry about that. Mike. Let's say get info. Now you can see name Mike, age 90, category teacher. I have successfully overriding this particular method called get info that is originally in the parent class. Which is this here. Normally the default one just prints the name age, but by creating a new method using that same name, that same name, Python is going to pick this one instead of the one in the parent class. So that's how you can override parent methods or parent classes. Okay, so then you can also override the initialization method as well. So for example, you want to extend the initialization method. So for instance, this person, let me just copy. Let me copy this into put it here. So what's happening here is that we create our own init method. Okay, so this init method is going to take an extra parameter. So let me call this. Remember the original parents add name, add age. Now we're going to have let's say cost. Let's say cost thoughts, for example. If that's correct. Okay, so we'll have the original name, the age that the parent class is going to need for initialization, and we also have courses thoughts, an extra parameter that we want to use. Okay, so what we'll do, this name and age, we'll pass it to the parent initialization method. So what we can do is, this is a new attribute we want to add. So we have set.courses, let's say course, let's say math, for example. How do I say mathematics? Gymnastics. Okay. Then after assigning this new attributes, we are going to make a call to the parent initialization method. So you can see we have super. This super means call the super class or call the parent class and call the initialization method. Now we're going to pass in name and age. Okay. So what we've done is that we've overridden the original initialization method, we've added an extra parameter, then we've passed in this normal parameter to this parent initialization method, and we've added our own extra attributes. So now if we run this class and we try to create a new object from teacher, we're going to throw an error because we are missing this parameter courses taught. So we have to add that extra parameter, which I'm going to add. I'll just simply call this. Oh, sorry about that. I think I had coded it here. So I'm supposed to do something like this. Course taught. So let me call this mathematics. So as soon as I run this, okay, it's going to initialize properly. Now, Mike now have access to a new attribute called courses taught. And it also have access to the former attributes called name from the parent class, as well as age from the parent class. So this is how you can override parent method. You can override any method that's in the parent class. It can be the initialization method. It can be a function by just creating a function with the same name and defining your own method. So Python is going to call this. It's going to give this one a precedence over the parent class method. Okay. So let me see. I think that's So that's all. So I don't know if there are any questions, strong questions. You don't understand a particular concept, a particular part. I would just like to take some quick questions. But before I do that, let me just quickly run through everything from the top very quickly. So Object-oriented programming, I said, is a programming paradigm that provides a means of structuring or combining data structure that belongs to a particular object into a single class. Okay, so you have a class and you define the properties of that class, the attributes, what functions that class is supposed to have. So that class becomes something like a blueprint for you to create new objects or new entities or new instances. Okay, so once you create an instance from a class, it takes all the properties and the methods available in that class. It automatically gets all those properties. Okay, and I said it helps to make your code readable, modularize your code, make it easy to debug, make it cleaner, and stuff like that. And you can do more complex stuff because you are actually defining your own data structure. Okay, so and what we did is I showed you how to define a class. So we talked about the primitive structures that are available in Python. Then defining the class is simply extending the data structure to your own taste. Okay. To define a class, you use the class keyword, which is always in lowercase, and you the name of your class, which always by convention should always start with capital letter. Or you can also call this camel case. So if you have maybe something like student new, something like this, so you can see the first letter of each new word is always capitalized. So it's called camel case. Okay, so you have this. This is how to define a class. Now, each class should have shoes. It's not compulsory, but you can decide to define an initialization method. Initialization method always starts with double underscore, and I told you that these are called dunder methods. Okay, they are inbuilt methods. So what you are doing here is simply overriding this initialization method and creating adding attributes. So we have name, age, this and this. Now what you are doing here is assigning that attribute to every instance. So anytime you create an instance, you always take the values that it was used to initialize and assign them to itself. Okay, this is so that you can access these attributes later. That's what we did there. Then to instantiate a class from an object, just instantiate an object from a class, you just simply call the class name and pass in the parameters in the right order. Okay. If you decide to specify the names, you can pass them in any order. But if you are using this positional index, sure you do like this. Okay. And to access attributes, you just use the dot method. So dot something, so it can be dot name, dot age, dot this. But in the case of methods, you have to add parentheses to it. Okay. Then we talked about attributes which have explained at the top. We talked about methods which are behaviors that each object or each class should have. So I said objects can return methods always perform a computation. So they might return a value or they might change the state of the class. So you can define methods like this. And note they must always have the set parameter at the start. This must always be in your method. Even if your method is not taking as a parameter, you must always add the set parameter to it. Okay. Then we did some examples of how to access methods. Then we talked about class inheritance, where I said I'd have a class, a super class or a parent class, and you might have children inheriting from that parent class. So it helps for you to you can extend attributes of your parent class. You can have access to attributes defined in the parent class without writing your own attributes again. And we also said that you can extend the attributes, meaning you can add new attributes even after inheriting attributes from the parent class. Then also lastly, we said you can override parent methods. So for example, you don't like the way the parent method is written or it is not customized enough for you. You can decide to override it by using the same name as it is used in the parent class. You can use that same name. So Python would call this instead of calling the one in the parent class. And you can decide to put in your functions here. So that's what we have. So questions? Are there any questions? I'm taking questions at this time. Issues, or is it clear? Okay, the area is kind of quiet, so I'm assuming there's none. Okay. That means I'm a great teacher. I don't have any questions. I don't have any questions. It was so clear. Wow. Okay, I think I'm good. Hi, Emmanuel. I don't think Emmanuel is on the call. Hi, Jasmine. What did you all go to?
Um, it's been a nice session, Rising. Probably once if there's any question, maybe further question. But I must say it was a very nice session. So it was a very nice session. So um, sure. Once they have any question, um, they'll push it to you. But for now, maybe they didn't digest it. Those who could share it across. So
All
nice
right, thank
session.
you very much. I really appreciate it. Thank you very much. So I'm happy. I was I enjoyed myself during this session. I'm looking forward to the next one as well. So thank you very much, and have a great day, everyone. Stay safe. Oh, I think Emmanuel is back.
Thank you. Thank you, Rosa. Cheers, everyone.
Bye.